Hello and welcome to the course of Material Science and Manufacturing Process. In this course, what we are doing in this course, we are concerning about the machining process. This is the fourth module. So here, this is the 22nd lecture of the fourth module, named as Rake mechanism of chip formation and type of chips. So let's start our lecture. The main lecture objective is to introspect about the mechanism of chip formation. Means we will study about mechanism of chip formation. Next we will understand about chip flow through rake and effect of the uh, what are the effect of the rake, that we will see, and we will see about the what are the different types of chips. So first, the mechanism of chip formation, how the chip is formed. So for chip formation, first what happened, a wedge shaped tool is made to move relative to the workpiece. So that means a wedge shaped tool. Wedge shaped means a V shaped tool, that is V shaped. This is V shaped tool, this is V shaped tool. That cutting tool I have shown in the last lecture. That V shaped tool is forced to move in the workpiece. So when it is forced to move in the workpiece, this tip, this tool tip, or this nose edge, this edge makes contact with the workpiece, which exert, and this, by making contact, it exert some force on the metal due to, and that force is compressive in nature. So in that portion, in that, due to those, that compressive force, what is happening, some deformation will occur, and that deformation will induce some shear in the metal. And as the as the shear is, as the force is increased, that induction of shear is also increased, and the metal starts moving over upward along the face of the tool. So when it is moving upward along the face of the tool, that face, that exactly that face is known as rake face. And the tool, as the tool advances, the shearing process goes on increasing and material is removed. See, see, in that case, what is the process? In the process is, when the tool is uh, coming into contact with the workpiece, what is happening, at this position, at the tip, a compression is given. Due to this compression, a stress is induced, and due to this stress, shearing occurs. And this shearing, due to this shearing, material is forced to remove, and it moves in this direction. And this direction, this chip flow or movement of the chip, is guided by our rake face. It is guided by our rake face, and this is rake face. And this face opposite to rake face, this face is flank face. Okay, so this is, and this plane is shear plane, this is the workpiece. So this is how the chip is formed in the machining process. So this is a general definition or general process of chip formation. Means from this we can conclude that chip is formed due to shear deformation. Now the nature of shear deformation is different in case of ductile and brittle material. In case of ductile material, we will see, in case of ductile material, when the shear, when the shear deformation, or when the compression is there, or when the pressure is there, at that place shear stress is generated, and due to continuous generation of shear stress, a crack may create, and that crack propagates slowly through the workpiece, and it won't so we can get a continuous chip in case of ductile. And the chip will be formed from the primary deformation zone, and there is another zone, that is secondary deformation zone. That secondary deformation zone is mainly due to the friction of the chip on the rake surface of the tool, that is our secondary deformation zone. But in case of generally when the machining is done at high speed, in case of ductile material, the secondary deformation zone won't create any problem, so we can get continuous chips uh, due to shear deformation in case of ductile material. Now in case of brittle material, what is happened? So first, due to this shear deformation, what is happening? Due to this shear deformation, our uh, workpiece, the chip, in the chip tool interface, where small cracks are generated. Due to these small cracks, those cracks will contain stress concentration, and that in those cracks, when this stress concentration are increasing, then abrupt breaking is occurred. So due to this abrupt breaking, discontinuous chip can form, and these discontinuous chips are of irregular shape and size. So that is how the in the brittle material, the deformation occurs due to stress concentration. But in case of our in case of ductile material, there won't be any stress concentration. That the deformation is done due to simple shear deformation through the primary deformation zone. And in that primary deformation zone, what is happening? The primary deformation zone for ductile or for any material, for brittle, each and every material, this deformation zone is thought like a plate, and these plate are very thin, so that the from the start of the deformation zone can be named as a shear plane. Now we are talking about now this is the mechanism of chip formation. Now we can see that what is rake and how this rake surface can be can give us the surface finish, or what is the effect of this rake, and what are the variation of this rake, those are possible, and what are the advantages and disadvantages of having this type of rake. So rake what rake does, the main function of rake is to remove the chip from the workpiece. This function can be done by using rake surface. So chip flows in the rake surface, and the rake angle is the measure of that rake face or measure of the rake surface. So now rake surface can be positive, or rake angle can be positive, it can be 0, or it can be negative. When it is positive when we do positive rake angle, when the chip formation is high. That means in case of ductile material operation, when the chip formation, when there is continuous chip formation at a high rate, then what we do, we use positive rake angle, so that chip can be formed, where chip can be flow out very easily. Next, in case of zero rake angle, what is happening? In case of zero rake angle, strength of the workpiece is increased, but the friction between the chip and tool also increases. So that is this zero rake angle case also can be used for specific requirement. And in case of negative rake angle, those negative rake angle has been provided due to due to high, when we need high hardness of the workpiece, so that it won't break in the heavy application. So that's why the negative rake has been provided into the workpiece. Now we will see about types of chip. There are three type of chips. First one is continuous chip, second one is discontinuous chip, and third one is continuous chip with built up edge. So continuous chip means those chips which has no breakage or not segmented chips. Those chips which are not segmented and doesn't have any breakage is known as continuous chip. Now this continuous chip or this continuous chip segment can be made by using ductile material with high cutting speed. So when the ductile material such as mild steel or such as aluminium, such as copper, this type of ductile material when they are machined with high cutting speed and the friction in the chip tool interface is very low, what happened, this continuous chip can be formed, and this continuous chip are very much this type of, for the continuous chip formation, the workpiece material means the surface finish of the machine surface, the machine surface or surface finish can be achieved very good, and the continuous, due to continuous chip formation, heat can be very easily carried out by the chip for whole time, means up to what time, means whenever you are doing machining, at that time when the continuous chip is formed, there we can say that maximum heat is continuously taken out by the by the chips, and in case of continuous chip formation, additional chip breakers should be used. Those additional chip breakers those additional chip breakers are used so that the to manage the length of the chip. So that's why continuous chip can be formed, and in case of another type of chips, we can see that are discontinuous chip. This discontinuous chip mainly formed due to brittle material operation or brittle material machining, and in that material machining, what is happen? Discontinuous chip means those chips which are not continuous. That means there is breakage, and this can be formed by when machining of brittle material such as brass, bronze, cast iron, etc. And this discontinuous chip, this can be formed due to stress concentration or micro cracks that is generated by due to stress concentration. So this discontinuous chip formation, this is also uh, in discontinuous chip formation, the their need of cutting fluid is very less, as the chip formation is very easy because the material is highly brittle. The break or the crack will be generated very easily. So that's why in some time say people said that cast iron is easily machinable. So this machinability does not depends upon ductility or brittleness. This machinability depends upon various factors by which we can determine which material can be machined easily and which is not. So in case of discontinuous chips, those material which can in which discontinuous chip can be formed, the machining is somewhat easy. So that's why it has good machinability. Now built up edge formation. So what we are saying, in the when we are dealing or when we are machining ductile material, at that time what is happening, when we are machining ductile material, the shear deformation is taking place on the primary deformation zone or shear plane, and then in when the chip is flows over the workpiece, at that time due to friction, some of the material of the workpiece, due to friction, some of the material of the workpiece got stuck or got welded with the chip, and that chip will force that small amount of material out of the workpiece. So this process, this phenomena is known as built-up edge formation. Now this built-up edge formation is not necessarily a good phenomena, because due to this built-up edge formation, the tool life or wear of the tool is increased very much. So that's why built up edge formation should be avoided, and the built up edge formation is mainly due to machining of ductile material with high friction of at chip tool interface. So due to this high friction, what is happened at the chip tool interface, the temperature will be increased more than the melting point temperature of the cutting tool or cutting tool material, and that cutting tool material is pressured also by using the bulk of the chip. So so that's why it's stuck into the workpiece by by welding. Now this is the process of built up edge formation. This built up edge formation is always is very important. This come into semester as short note. Now, what are the factors that affect the chip types of chip? The factors that affect the type of chips are what is the nature of workpiece? That means what is the workpiece? Is the workpiece is ductile or brittle? That is the first criteria. Second, what is the tool? The tool is hard or not hard? Tool is what type of tool is used? That is second. Next, tool geometry or dimension of the tool. Third is cutting parameters such as feed, cutting speed, and depth of cut. Next, other cutting conditions such as temperature, lubrication, etc. And tool workpiece friction. The friction that whole chip formation is highly depends on the friction in chip in tool in chip tool interface. So thank you, that is it for today. In the next lecture we will be seeing what are the we will be seeing some mathematical derivation and mathematical formulas. So till then, thank you for being here. If you have any question, you may ask in the live class.